Hello, Algebra 1. All right, we are looking at a brand new lesson today. So I'm going to try to keep this short and sweet. That's kind of the goal for all of these. So quadratics, this is whenever the highest exponent is a 2. We were looking at this before spring break. All of your quadratic graphs are parabolas. They either open down or they open up. So this lesson today that we're looking at really is a lot of vocabulary, okay? So the first word I want you to know is vertex. And vertex is either the highest point of the graph or it's the lowest point of the graph. All right, the two sides come together at the highest point or the two sides come together at the lowest point. And that point where they come together is your vertex. So that's the first vocab word, vertex. When the vertex is the highest point of the graph, it's called a maximum. And when the vertex is the lowest point of the graph, it's called a minimum. And hopefully that kind of makes sense. That's the lowest point, so it's a min. That's the highest point, so it's a max. Okay, another word I want you guys to know is called the axis of symmetry. The axis of symmetry is a line that splits a shape in half. Okay, so in this picture, the axis of symmetry would be this line right here that splits the parabola in half. And for this picture, it is the same line that splits the parabola in half. Do you remember that vertical lines are called vucks? So if I wanted to write an equation for my axis of symmetry, it would end up being x equals, because x is the last letter of vucks, and then I would just need to know what my x value is everywhere right here. And my x value is a 0. So that would be the axis of symmetry for this graph as well as the axis of symmetry for this graph. But that is not always the axis of symmetry, so we'll look at some problems in a second where it's a little different. But it will always be x equals because it's always going to be a vertical line that splits the parabola in half, and vertical lines are always vuxes, which means they'll always say x equals. Okay, there's other stuff on this page. You can kind of read it for yourself, but I'll talk about it as we try the next couple problems. All right, so just so you know, I am looking at the notes that are on your Canvas calendar, and so you could be looking at them at the same time. You know, I'm instructing if you wanted, and you can print them off if you were able to print them off. But if not, you can just watch this and you can soak it in. And if you want to take notes while I'm working, you can. But if you don't want to, that's okay too. Okay, sometimes you can understand a lot just from watching and listening and paying attention. And if you needed to replay the video because you forgot, you could always replay the video because you forgot. All right, so I am just going on to the next page. And so the next problem, we're going to find a whole bunch of things. All right, so the first thing up is the vertex. And I said a second ago, it's either the lowest point or the highest point of the graph. So this guy is my vertex because it's the lowest point. In number 3, the vertex would be this guy because it's the highest point. So it's where the two curves come together. All right, so if this is my vertex, I need to know what it is as an ordered pair. So remember, x comes first, y comes second. So your x value is 2, because you go right 2. And your y value is 0, because you're not up or down off of the y-axis. Okay, then I want to know if it's a max or a min, and what the max or min value is. Since this is the lowest point of the graph, it is called a min. It's a minimum. Now, I only want one number here. So max and min wants to know how high something is or how low something is. So I want to know how high or how low that is. Which of these numbers do you think talks about how high something is or how low something is? An x value or a y value? Who talks high and low? A y value does, because the y value is up and down. That's high and low. So if I want to know the minimum value, it's going to be the y coordinate of the vertex, which is 0. That's how low that guy is at 0. Okay, the axis of symmetry. This is the vertical line that splits the parabola in half. And all vertical lines are vuxes, so it's going to be x equals, and then what's your x value everywhere on this line? 2. So that's your axis of symmetry. Okay, the next two things don't want to know where P and Q are. They want to know where the points corresponding to P and Q are. Meaning, if you were to flip P over this axis of symmetry, where would it land? All right, so P would have to go right 1 to hop on the axis, which means it would have to go right 1 again to get to its reflection point or corresponding point. This is P's new point, which as an ordered pair, you go right 3 and up 2, so that's the point 3, 2. So these 2 points are the same distance from the axis of symmetry. They're called corresponding points or they're called reflection points. So when I'm looking for the corresponding point to Q, I want to know where would Q be on the other side over here. So remember, it's going to have to be the same distance from the axis of symmetry as this guy is. So to get to the axis, I have to go twice to the left, choop, choop. And so I go left twice again, choop, choop, to get to its corresponding point or reflection point. And to get to that guy, you don't go right or left, so your x is 0, but you do go up 8, so your y is an 8. And that's the corresponding point to Q. So corresponding points, they're where they would land if you flipped it over the axis of symmetry. All right, domain and range. This is what I talked about in the last lesson. Domain are x's. This is left and right. This graph goes forever to the left. This graph goes forever to the right. So that's all real numbers. Range, these are your y's, and y's are up and down. I can see the graph goes forever up, but not forever down. So I'm going to find where my y begins, and my lowest y value is here at 0. So the y equals a 0, and as you go up, 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 y's get greater. So that's your range. All right, and then this word zeros. Remember, it's also x-intercepts, roots, and solutions. We talked about this before break, but it's been a while. So zeros are x-intercepts, roots, and solutions. All 4 of those words mean the same thing, and it's wherever the graph touches the x-axis. And I only have 1, and so I'm going to say my 0 has an x value of 2. And that's at 0. Okay, now look at number 2 for a second. When it asks for its zeros or roots or solutions, where does this graph touch the x-axis? Does it touch the x-axis at all? No. So there aren't any zeros or x-intercepts or roots or solutions. So I'm going to say no real number solution. So a graph has to touch the x-axis in order to have a zero, a root, a solution, and x-intercept. And since it never touches the x-axis, there's no real number solution. Okay, let's look at number 3 because I want to look at a graph that is opening down. So this one opened up. Now let's look at one that opens down. All right, so the vertex, remember, it's either the lowest point or highest point. So this time my vertex is the highest point. So as an ordered pair, do you know who that is? It's 0, 8. You don't go right or left, so your x is 0, but you go up 8. All right, since it's the highest point, it is called a max. Now, I want to know how high it is. So remember, it's always the y-coordinate that tells you how high or how low something is. So the max value right there is 8, because that's how high that graph gets. Right, the axis of symmetry is the vertical line that splits the parabola in half. All vertical lines are vuxes, so it's going to be x equals. And what's your x value? Everywhere right here. Your x value is 0. Okay, now P. I don't want to know this P. I want to know where P lands when you flip it over the axis of symmetry. Do you happen to know what it is without me telling you? If anybody guessed it, it's 1, 6. So I can figure out how to get to the axis of symmetry. I'd have to go right 1 to get to it, and then you just do that again. Go right 1 again. And that's where P would land if you flipped it over your axis of symmetry. Okay, where do you think Q would land if you flipped Q over the axis of symmetry? If any of you guessed it, it's -2, 0. So to get Q to the axis, I'd have to go left twice, choop, choop, and I'd have to go left twice to flip it, choop, choop. And -2, 0 is where it would land. So if you're struggling with this, decide which way and how many do you have to go to the axis, and then do it again. So like to get P to the axis, I went right 1, so I go right 1 again, boop, and that's where he lands. To get Q to the axis of symmetry, I have to go left twice, choop, choop, so I go left twice again, choop, choop, and that's his corresponding point or reflection point. Okay, domain. This graph, I want to know what it's doing left and right, because domain are x's. So as I cruise to the left, it goes forever left. As I cruise to the right, it goes forever right. So domain is all real numbers. And that should always be the domain as long as we have a graph with arrows on both ends. So forever to the left, forever to the right. Same thing down here, forever to the left, forever to the right. Okay, range. It does go forever down, but not forever up. So I'm going to find where my y begins, because range is about y's. So my highest y is an 8. So my y starts out at an 8. And then what happens to y's when the graph goes down? As the graph goes down, y's get less. All right, and then zeros, these are your x-intercepts, roots, and solutions. So it's wherever the graph touches the x-axis. So right there and right there. What's that x value? -2. What's that x value? +2. So -2 and +2 are our zeros. All right, what I want you to do for me is I want you to do number 2. Now, I'm not telling you that you have to draw this graph or anything. If you had this paper printed out, then you could just work this problem on the piece of paper. If you don't have this problem printed out, no big deal. I just want you to answer these questions on a blank piece of paper, and then I want you to take a picture of your answers, and I want you to put it on Canvas. So there will be a Canvas assignment for you to upload your picture, and then you'll just do that so I can look at it and see how you did. Okay, so either if you have the page printed off, you can just do the work right on there, or if you don't have the page printed off, you'll just, on a separate piece of paper, write down vertex, the answer, max min, the answer, axis of symmetry, the answer. Okay, try it. Let's see how you do. And that's all for today. Smiley face.